Hello, ladies and gentlemen. This is Mr. Hunter, and this is part 3 of your projectile motion notes. This will bring us to the end of the unit, as well as the last content that we need to know for kinematics. So in our last example, a ball is being launched at an angle of 43 degrees to the horizontal with an initial velocity of 15 meters per second. Now, as I stated in class, it's always good to draw a picture. So here's our horizontal, and it says a ball is being launched above it at 43 degrees with a velocity of 15 meters per second. This is the resultant velocity, so the first thing that we need to do is we need to break it into its horizontal and vertical components. And then once we do that, remember, we discard the original number. We never need it again. It's dead to us. So we need to break this into its x and its y. So we need its initial velocity on the x, and we need its initial velocity in the y. And just like in class, we have to use the SOHCAHTOA stuff to get the angle. So if I want to solve for opposite, VIY is opposite of my angle, so that I have to use the sine function, and it's sine theta equals VIY over my hypotenuse, right? So then now I just plug in numbers. I have sine of 43 equals VIY over 15. I cross multiply. So when I cross multiply, I get VIY equals sine of 43 times 15. And that gives me a value of my initial velocity in the y of 10.2 meters per second. And then we have to do the same thing for VIX. VIX would be cosine because it's adjacent to the angle. So cosine of theta equals VIX over hypotenuse. So when we plug in, I have cosine of 43 equals VIX over 15. When I cross multiply, and for the sake of time, I'm just going to put the answer. I get VIX equal to 11 meters per second. Now, once again, now that we have its x and y components, we totally disregard that 15 meters per second. We never use it again because we don't need it. So this is what I'd like to do in your notes. Just to give you a warning, you're probably going to have to continue these notes on a separate sheet of paper because we're about to do a ton of calculations. Now, that's the only new part, is getting the VIX and VIY. Everything else that we're about to get is the same that we've done before. But in this example, I'm going to launch a ball. So here's the ground. I'm going to launch a ball, and it's going to follow projectile motion. So I launched it at 15 meters per second. And so we're about to figure out our distance in the y. We are going to figure out our distance in the x. We're actually going to also figure out the total time in the air. We're going to figure out the final velocity in the x and the final velocity in the y. And I believe that's all the variables we need. So what I'd like you to do is make this table in your notes. This is the projectile motion table. And remember, because x's and y's are like oil and water, they don't mix. So you have to treat them independently. So we just found our VIX. Our VIX came out to be 11 meters per second. And our VIY equals 10.2 meters per second. Now, in this table, we can just start listing things we know. For example, we know our acceleration in the y. In this case, I have to say acceleration is negative 9.8 meters per second. And here's why. Meters per second squared. Because the problem said, hey, you're shooting 43 degrees at 15 meters per second. So it just dictated that up and to the right is positive, which means down and to the left is negative. So I have to keep that. Now, we also know our acceleration on the x. We are ignoring air friction. So the acceleration on the x is 0 meters per second squared. Just review, forces cause an acceleration, and acceleration causes a change in velocity. Because we have no force on the x-axis, we have no acceleration. Because we have no acceleration, we have no change in velocity. So my final velocity in the x is 11 meters per second. Ladies and gentlemen, that number doesn't turn negative. It didn't magically start going the opposite way. I say that because a lot of students will put that number as negative for some god-awful reason. So you got to keep that positive because my initial velocity in the x is 11 and my final is also 11 because I didn't change direction and there's nothing to change my velocity. The thing we don't know is my distance in the x. We don't know how far it goes. We also don't know time, and time works in both axes, obviously, but remember that you only use y for time. We only use the y-axis to figure out time. Why? Because the acceleration due to gravity is what dictates how fast that object gets to the ground. Okay, so do we know anything else in the y? Yes, we technically do. Because as I stated in the first example, when I launch an object up at 30 meters per second, the time it gets back to the same point, it's moving at the same speed, but in the opposite direction. So my final velocity in the y is negative 10.2 meters per second. Negative because it's going down, and as we've already mathematically demonstrated, it's moving at the same speed by the time it gets back to that point. So we don't know our time, which we're going to use y-axis to get. We do not know our distance in the y, which is what we will solve for afterwards. Now, I'm going to show you both ways to solve for these things, but remember, since we know the final velocity in the y, let's actually do that right now. So that is our LEPA part. So I have VFY equals VIY plus AY times time. Now, there's two ways to do it. You could do it like your hang time. You know that at the top of the motion, my VFY equals 0 meters per second at the top. We know that my VIY equals 10.2 meters per second, and there we also know that our VFY equals negative 10.2 meters per second because I've already proved it mathematically in the other example. So the easy way would be, hey, negative 10.2 equals 10.2 minus 9.8 times time. If you're curious where I got the minus from, it's negative 9.8. A negative times a positive is a negative. So then now I have to solve for the t. So I got to get the 10.2 away. So I subtract it out. So I get negative 20.4 equals negative 9.8 t. Divide by negative 9.8. Divide by negative 9.8. And plugging this in my calculator, I get an answer of the time it takes, the total time that it is in the air is 2.1 seconds. So the total time it's in the air, so let's go fill that back in our table, is 2.1 seconds. So the time it's in the air is 2.1 seconds. Now, the other way we could have solved this is using the equation. It's just like your hang time. I know, so the other way to solve this was VFY, and just to give you a heads up, this video is probably going to be over 10 minutes, so you're just going to have to bear with me. Okay, so VFY equals VIY plus AYT. So one thing you could have done is said, okay, I know this is 0 at the top, because from here to here, I know my final velocity equals 0 meters per second, which equals 10.2 meters per second minus 9.8 t. And so once I do the math, I got to get the 10.2 off that side. So I get negative 10.2 equals negative 9.8. And then t, then when I divide that out, I get t equal to 1.05 seconds. However, that's only the time going up. I also need the time going down, so just like in your hang time lab, I would multiply this by 2 to get 2.1 seconds for the total time in the air. Okay, now that we have that, let's move on to getting our distance in the y. So how high did the object go? Well, we have d of y, we have a of y equals negative 9.8 meters per second squared. We have VIY, which is 10.2 meters per second, and we know our time, but in this case, we only want the time from the top to the bottom because we're trying to figure out the height. So we're actually going to use at 1.05 seconds. So what equation do we use? There's two that we could use. We could use, we also know that our final velocity at the top is 0 meters per second. Now, I can use two equations. I could use dy equals VIYT plus 1/2 AT squared, but that would be a ton of math. Because I have initial velocity, it doesn't go away. I'm actually going to have to do a lot more steps, but this equation's easier because it's less math. VF squared equals VI squared plus 2AD. Because I don't have to deal with squaring the time and multiplying it by this and then adding them together and yada, yada, yada. So in this case, I have 0 equals 10.2 squared minus, because this guy's negative, 2 times 9.8 times dy. Now I solve for dy. So 10.2 squared equals 104.04. So minus 104.04 minus 104.04. So I have negative 104.04 equals negative 2 times 9.8 would be negative 19.6. So negative 19.6 dy. So then I divide out the negative number. Negative 19.6, negative 19.6. So 104.04 divided by 19.6 equals, so our distance in the y, or our height, came out to be 5.3 meters. So it went 5.3 meters up in the air. So let's go plug that back in. So our distance in the y is 5.3 meters. And now all we're left with is getting our distance in the x, and then we're done. So our distance in the x is a question mark. Our acceleration in the x is 0 meters per second squared. Our initial velocity in the x equals 11 meters per second, and our total time in the air was 2.1 seconds. Right? So when I look, I could see that d of x equals vix times time plus ax t squared over 2. But I know that this guy is 0, so this all gets canceled out. So this guy is just 0. So if I rewrite this, I really have d of x equals vix times time. So now I just plug in. I have d of x equals 11 times 2.1 equals 11 times 2.1 equals 23.1 meters. So this object, when it got launched, was 23.1 meters away from where it started. So let's just draw a picture of everything we just figured out. Come on, smartboard. And you want to be funny. Okay, so we launched an object. And we found that its initial up velocity, so VIY, equaled 13.2, not 13.2, I am making up numbers, 10.2. Please tell me I was using 10.2 and not 13.2. Anyways, I'll go back and check that. The math, how you do the math is still the same. The VIX equals 11 meters per second, right? We found the total time to get from there to there was 2.1 seconds. And we found that our x distance was 23.1 meters. We found our height, dy, equals 5 point something. I can't remember the number off the top of my head. And so we figured out, and we also know that VFY equals 10.2 meters per second, and we know that VFX equals 11 meters per second. So as I stated in class, if you master this, you've mastered everything about projectile motion that you can possibly do. Okay, this will be due on Monday, so I will see you with it then.